Okay, we're going to start this course looking at accuracy and precision. So in accuracy and precision, what we're going to look at is understanding the difference between accuracy and precision, and also determining the importance of degrees of accuracy and precision. So the outcomes we're going to cover include explaining why in a given context a certain degree of precision is required, explaining why in a certain context a certain degree of accuracy is required, explaining using examples the difference between precision and accuracy, analyze precision and accuracy in a contextual problem, compare the degree of accuracy of two given instruments used to measure the same attribute, describe using examples the limitations of measuring instruments used in a specific trade or industry, and relating the degree of precision to the uncertainty of a given measure. Okay, so first we're going to look at a couple of definitions. First definition is accuracy. Accuracy is the degree to which a measurement is measured and reported correctly. In simpler terms, it is how correct your answer is, how right your answer is. Okay, so if I wanted to accurately measure the angle that's drawn on the protractor here, I have two options. It could either be 130 degrees approximately or 50 degrees approximately. So I have to determine which one is the accurate answer. What you have to remember is that one of the rays of your angle always has to pass through 0 degrees. One of the rays passes through 0 degrees using the inner set of units on this protractor, which means that my angle is going to be measured accurately using the inner units on this protractor. So I have two options here. One is it's a 50-degree angle, and the other is that it's 130 degrees. The inner units on my protractor tell me that the answer is 50 degrees. 130 degrees is much too large for an angle of that size. Okay, so that's accuracy. Precision is the degree of exactness to which a measurement is expressed. In other words, how much detail, I guess, you can provide to your answer. The precision of a measurement depends on the scale of the instrument used. So I've said here that this accurately can be measured as about 50 degrees. However, you'll notice that it doesn't quite reach 50 degrees, the 50-degree measurement on the protractor. It's a little bit less. It's actually about 48 degrees. So more precisely, I could say, because I can measure to the nearest, I can measure by degrees. Every tick mark on my protractor is a degree, that it's about 48 degrees. But if you're really paying attention, you'll notice that the angle actually is between 48 and 49 degrees. So even more precisely, I could say that the measure of this angle is 48.5 degrees. Okay, so that's a more precise measurement. I can go to basically one unit more precise than the actual units given on the measurement on the device. The device is divided up into degrees. Well, I can attempt to estimate what it would be to the nearest tenth of a degree as a result. So 50 degrees is an accurate answer. But 48 is accurate as well, and 48.5. They're all accurate answers. However, of the three, 48.5 degrees would be considered the most precise answer available. Okay, now we're going to look at a couple of examples trying to determine accuracy and precision. So the first question here is determining accuracy. Vic and his son are going to pour a concrete pad before building a shed. They want the pad to be 12 feet long, 8 feet wide, and 4 inches thick. Vic's son wants to calculate the volume of the concrete needed. He knows that volume for something of this shape would be length times width times height, or in other words, the thickness of the slab. So he measures, or he calculates that volume is equal to 12 times 8 times 4, and he gets an answer of 392. Vic Sun says, we need 392 cubic feet of concrete. Vic says, no way, we only need 32 cubic feet. So the first question is, whose calculation is correct? Explain. Well, first off, Vic Sun is correct that volume can be calculated by multiplying the length times the width times the height, 12 times 8 times 4, as he has written. However, he's forgotten one thing. 12 and 8, those values are given in units of feet, whereas the 4 is given in units of inches. So we can't really calculate the volume of something using two completely different units of measurement. So what we have to do is convert 4 inches into feet. Okay, so 4 inches, we know that there are 12 inches in 1 foot. So we have 4 inches. It would give me 4/12 of a foot, which can be reduced to 1/3 of a foot. So if we calculate the volume using 1/3 of a foot instead of 4 inches, what we get is that the volume is equal to 12 times 8 times 1/3, which does work out to be 32 cubic feet. So who is right? Vic is right. We only need 32 cubic feet. So is it important for the calculation to be accurate? Explain. Well, if we went by Vic Sun's calculation, 392 cubic feet of concrete would be necessary. The actual answer is that, the accurate answer is that we only need 32 cubic feet of concrete. So if we went by Vic Sun's calculation, we would have bought 360 extra cubic feet of concrete. So that's quite a bit more than is needed, and what are you going to do with it? So it is important that you get an accurate answer. Okay, now we're going to look at the importance of precision in calculating values. Greg is redecorating a bedroom in his house. He knows that his measurements need to be accurate, but the degree of precision required depends on the job. So in A, Greg wants to determine how much paint to buy. The dimensions of the room are 12 feet 8.5 inches by 10 feet 10 inches, and the ceiling is 7 feet 10.5 inches high. What degree of precision does he need for the room's measurements? How much paint should he buy? Well, if you buy paint, you can buy it in either the quart or the gallon, usually, which is roughly 1 liter or 4 liters. So there isn't going to be a great deal of precision needed when you consider how many different options you have really available to you. So if we're considering that Greg wants to put 2 coats of paint on his room, he can round the values for the units of his room, for the lengths of his room. It's about 13 feet long by about 11 feet wide by about 8 feet high. He doesn't have to be very precise here because, again, he's buying paint by either the quart or the gallon. So what he'll do is first measure the area of the 2 long walls in the room. They're both 13 feet long and 8 feet high. So that works out to be 2 times 13 times 8, or about 208 square feet. In the area of the 2 short walls, the 2 shorter walls are 11 feet long. So it's 11 feet long by 8 feet high, and there are 2 walls. So that works out to about 176 square feet. So the total amount of paint needed is about 208 square feet by plus 176 square feet times the 2 coats of paint. So he needs enough paint for about 768 square feet, or roughly about 750 square feet, because if you notice, if we go back, there's a door and a window in his room, so they're not going to be painted. Greg is also replacing the door and window casing in his room. The door frame measures 80 inches by 30 inches. The door casing will be installed so that about 1/8 of an inch of the door frame is exposed. Greg needs to cut the pieces of the casing. What degree of precision does he need for the measurements? And how long should he cut the pieces of casing? So in a situation such as this, you're going to want to have a bit more precision in your work than you did when you were calculating how much paint you're going to need. Okay, so he'll need to add 1/8 of an inch to each of his measurements to cover the casings. So the height that he's going to have to cut his wood is 80 plus 1/8 of an inch, or 80 1/8 inches. The width he's going to have to calculate is 30 inches plus another 1/8 of an inch. So he's going to have to make precise measurement on his piece of wood. It would be 30 inches and 1/8. Okay, so to summarize, accuracy tells you how correct or how right a measurement is, how right your answer is. Precision tells you how exact a measurement is, how much detail you provide to your answer. Can you get away with rounding it, or do you have to give a lot of detail to your answer? A measurement could be accurate but not precise. In other words, it could be correct but rounded, or it could be precise but not accurate. So it could be an exact value, but it may not be correct. Okay, and we're going to look at a couple of questions that help us understand this a bit better in the next video.